Good morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today's our topic is data visualization using histograms. In last class, we have seen that data visualization using the bar charts. The bar charts are used for showing a data in the form of the bar graph or in the form of the rectangular format. And some that bar chart have different types: vertical bar graph, horizontal, then after that stacked or clustered. These are four types of the bar graph. But in vertical bar graph, just you can say that there are y-axis and the x-axis. Your data is on the are in vertical format. If your graph is horizontal format, that means you are showing your data in the horizontal format like this. Then again, if you are doing that is stacked format, that means you are showing a different groups, different categories in the single bar graph. And in the cluster format that means you are showing a data in the form of the groups. So these are the different visualizations by using the data, by using the bar charts. And even when you are plotting your bar graph, at that time there are some rules we have to follow. Your bar graph should be in the rectangular shape. Width of the particular graph should be same. Then after that, difference between the two bar graphs, it should be equal. So these rules we have to follow. Now we will move towards our main topic, that is histogram. Our contents are: what is histogram shape, and when to use the histogram. First, what is histogram? Actually, the histogram can be defined as a set of rectangles with bases along with the intervals between the class boundaries. When you will draw the histogram, that histogram will contain some set of rectangles, and it will show the intervals between the class boundaries. And each rectangle bar depicts some sort of the data, and all the rectangles are adjacent. The heights of the rectangles are proportional to corresponding frequencies of similar as well as for different classes. The histogram is graphical representation of data where the data grouped into continuous number of ranges, and each range correspond a vertical bar. Actually, your histogram is generally a graphical representation where your data will contain the number of ranges, and each range will correspond the vertical bar. And the horizontal axis generally display your number range, and the vertical axis represent the amount of data that is present in each range. The number of ranges generally depend upon the data that is being used. The histogram bar is a bar graph representation of the data. We can say it is a bar graph, and it is a bar graph representation, and it is a representation of the range of outcomes into the columns formation along the x-axis. In the same histogram, the number of count or multiple occurrences in the data for each column is represented by the y-axis. And it is the easiest manner that can be used to visualize your data distributions. For example, the histogram graph by plotting one for the given below example. Uncle Bruno owns a garden with 30 black cherry trees, and each tree has a different height. And now the height of the trees are like 61, 63, 64. These are the heights of the trees. And we can group the data as follows in the frequency distribution table by setting a range. Now, one column is for the height or height range and another is a number of trees. That means it is showing the frequency. Height of the range are 60 to 70. First is 60 to 70 and the number of trees are 3. Then 66 to 70 there are number 3. Then again 71 to 75 these are 8. 76 to 80 10. 81 to 85 5. And 86 to 90 there is only one tree. This is 60 to 65. So we have find out the frequencies of the trees. Now how we will plot? The data can be now shown using the histogram. We need to make sure that while plotting a histogram there should not be any gaps between the bars. Whenever you will draw your histogram, there should not be gap between the bars. So these are y-axis is showing the frequency and x-axis is showing the height. We have taken the scale as a 60, 65, 70, 75, 80, 85 and 90. And there is a frequency, how many trees are available. For example, 60 to 65, in the range of the 60 to 65, there are 3 trees. So we have drawn. Then 65 to 70, again we have 3 trees. Then 70, 75, we have 8 trees. Then 75 to 80, we have 10 trees. Again 80 to 85, 5 trees. And 85 to 90, we have only 1 tree. So we have drawn this histogram on the basis of our data. Now how to make a histogram? The process of making histogram using the given data is described below. First step, choose a suitable scale to represent weights on the horizontal axis. Then second step, choose a suitable scale to represent the frequencies on the vertical axis. That means on horizontal axis we have shown the weights and on vertical axis we have shown the frequencies. Then step 3, then draw the bars corresponding to each of the given weights using their frequencies. Now for example, construct a histogram for the following frequency distribution table that describes the frequencies of the weight of 25 students in the class. Now we have given the distribution table and distribution table is containing the weights and another column is a frequency. Weights we have in the range, we have shown in the range and frequency are number of the students. 65 to 70 we have 4, 70 to 75 10, 75 to 88 and 80 to 85 4. Now steps to draw the histogram. First, on the horizontal axis, we can choose the scale to be 1 unit is equal to 11 lb. Since the weights in the table start from 65, not from the 0, and we give a break on the x-axis. So our table will not start with the 0 and we will start with the 65. Then second one, on the vertical axis, frequencies are varying from 4 to 10. Thus we choose the scale to be 1 unit is equal to 2. Then draw the bars corresponding to each of the given weights using their frequencies. Now, see, there is a 65 to 70 range and we have drawn till 4. There are 4 students. Then 70 to 75, 10. 75 to 80, 8. And 80 to 85, there are 4. That means these are frequencies. Again, these are the weights which are showing in the lbs. Then after that, frequency histogram. The frequency histogram is a histogram that shows the frequencies, the number of occurrences of the given data items. For example, in hospital, there are 20 newborn babies whose ages in increasing order are as follows, like 1, 2, 3, 4 and 5. Actually, this information can be shown in frequency distribution table as shown as the figure follows. There is a 2 columns, age and the frequency. Again, there are the ages 1, 2, 3, 4, 5 and there are the frequencies age with age 1 year is 4, then 2, 5, 3, 8, 4, 2, and 5 with 1. So we have to draw the histogram. Again here there will be your x-axis and the y-axis. You have to mention your frequency on y-axis like 1, 2, 3, 4, 5, 6, 7, and then again you have to draw your histogram by using this data. Again x-axis is showing the age in days and y-axis is showing as a frequency. So between 0 to with the age 1 there are 4 newborn babies. So 0 to 1 4 new babies, then 5, then again 8, 2 and 1. After that, histogram shape. The histogram can be classified into different types based on the frequency distribution on the data. And there are different types of distribution such as normal distribution, skewed distribution, bimodal distribution, multimodal distribution, comb distribution, age peak distribution, dog food distribution, hard cut distribution, and so on. That means we have seen so many distributions in previous classes, and the histogram can be used to represent these different types of the distribution. And we have mainly 5 types of histogram shape, and they are listed below. First one is bell-shaped histogram, then bimodal histogram, skewed right histogram, skewed left histogram, and uniform histogram. Let us discuss the histograms one by one. First, bell-shaped histogram. And already a bell-shaped histogram has a single peak, and histogram has just one peak at this time interval, and hence it is called a bell-shaped histogram. Just for example, the following shows the number of children visiting a park at the different time intervals. That means there are different types of interval, and we have to draw the bell-shaped histogram on that basis. And here we have only single peak. So this histogram has only one peak, and the maximum number of children who visit the park is between 5:30 p.m. to 6 p.m. Now this is your bell-shaped histogram. Again, it is showing the time, and this is showing the frequency. And on this basis of the basis of this data, we are drawing our bell-shaped histogram, and this is your peak. That means this is your single peak. This is your single peak. And see here, between 4 to 4:30, there are only 20 visitors. 4:30 to 5, there are 30 visitors. Then 5 to 5:30, there are 40 visitors. And 5:30 to 6, there are 50 visitors. That means here on this point, we have got the one single peak point. And then 6 to 6:30, again there are 40 visitors. Then 6:30 to 7, there are 30 visitors. And 7 to 7:30, there are only 20 visitors. That means first your graph is increasing, and again your graph is decreasing. That means at the one point there is a one single peak. Only one single peak is available. Then second one is a bimodal histogram. The bimodal histogram has 2 peaks, and it looks like the graph given below. For example, the following histogram shows the marks obtained by the 48 student of the class 8 of St. Mary's School. The maximum number of students have scored either between 40 to 50 marks or between 60 to 70 marks. So this histogram has 2 peaks, 40 to 50, and another one is the 60 to 70. And hence it is called a bimodal histogram. Why we are saying bimodal histogram? Because we are getting here 2 peaks point. And there are 2 ranges, 40 to 50 and the 60 to 70 of the marks. That's why we are getting 2 peaks point. Now here you can see bimodal histogram. Again, there is a ranges 10 to 100 and there is a frequency 0 to 10. There are the marks. Again, here you can see between 40 to 50 there is a one peak, and again 60 to 70 there is another one peak. So that's why we are calling here it bimodal histogram. After that, skewed right histogram. The skewed right histogram is histogram that is skewed to the right. In this histogram, the bars of the histogram are skewed to the right, hence called the skewed right histogram. For example, the following histogram shows the number of people corresponding to the different wage range. And the histogram is skewed to the right. For example, for the maximum number of people, wages ranged from 10 to 20,000. Now, skewed right histogram. That skewed right histogram has again two axes, x-axis and a y-axis. These are wages and these are the frequency. So there is only one peak point, and you know the between the 10 to 20 there are so much frequency, that is our 50. Then this is your right skewed right frequency. Then now skewed left histogram. The skewed left histogram is histogram that is skewed to the left. And in this histogram, the bars of the histogram are skewed to the left side. Here, your bars of the histogram skewed to the right side. And here, your bars of the histogram are skewed to the left side, hence called a skewed left histogram. For example, the following histogram shows the number of students of the class 10 of Greenwood High School according to the amount of time they spend on their studies on a daily basis. And the maximum number of students study 4.5 to 5 hours on daily basis. Now, this is your skewed left histogram. This is the time and the frequency. Skewed left histogram means your bars are skewed to the left side. And you can see that between 4.5 to 5 hours, there are so many who are doing the study. Now, next one is uniform histogram. The uniform histogram is histogram where all the bars are more or less of the same height. And in this histogram, the lengths of the all bar graphs are more or less the same. Hence, it is a uniform histogram. For example, Ma'am Lucky, the principal of Little Lily Place School, wanted to record the heights of her student. And the following histogram shows the number of students and their varying heights. The height of the student ranges between 30 inches to 50 inches. Now, in uniform histogram, what will happen? Generally, the height of the bar graph will be the same. Mostly it will be the same. For example, 30 to 34 it is showing 7, 34 to 38 again 6, 38 to 42 7, again 6, again 7. That means near about the height will be the same. Now we will see the difference between the histogram and the bar graph. First difference is that the histogram is the graphical representation of data where data is grouped into continuous number ranges and each range is correspond to your vertical bar, and the bar graph is the graphical representation of the categorical data using rectangular bar where length of each bar is proportional to the value they represent. Equal space between the every two consecutive bars. If you are using the histogram, so at that time there should be equal space between every two consecutive bars. And if you are using the bar graph, then no space between two consecutive bars, they should be attached to each other. In histogram, x-axis can represent anything, and in bar graph, x-axis should represent only the continuous data, that is in terms of the number. This is the difference between the histogram and bar graph. Now, when to use a histogram? If you have a numerical data, so at that time you can use the histogram. And if you want to see the shape of the data's distribution, especially when determining whether the output of the process is distributed approximately normally, analyzing whether a process can meet the customer's requirement, analyzing what the output from the supplier's process look like, seeing whether a process change has occurred from one time period to the another, then determining whether the outputs of two or more processes are different, and you wish to communicate distribution of data quickly and easily to others. So these are your references, so you can go through these references, and this is all about the histogram. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.